Okay, so good day. So this is the second part of our video, and we will be doing a simple demonstration of the machine learning activity that we had discussed in the previous part of this lecture. So actually, I'm going to do this in Jupyter rather than my usual Spider, because as you can see here, we are going to run the code in chunks, and I find it much easier to run code in chunks in Jupyter. And aside from that, I am using it in a virtual environment. So as you can see here, this is because my system is Linux, so I activated my virtual environment first. So this is going to my the virtual environment folder and activating my virtual environment ML trial 01. So this is basically activating my Jupyter notebook, which runs on my locally on my system. So anyway, we will doing chunks of code here. Actually, I had here these chunks of code already, so I'm just going to copy paste everything because I'm lazy I'm lazy typing. Okay, so here is our first command here is to retrieve the data set. So again, I got this video, or rather I got the code, the data sets from a reference book, which is Hands-on Machine Learning by O'Reilly Publishing. So anyway, this sample is the source data in this sample is from a GitHub. So this particular command is going to fetch that data using your this is the site of the URL of the data. So we are just going to get the data, download the zip file, this TGZ, and extract the TGC. So extract the data. So I'm going to run it. So, okay, so you have it's already run, and then the next one is to load that data into the data frame. So this is a pandas data frame. So by the way, in your virtual environment, since this is a virtual environment, you will be starting, if you just have created a new virtual environment specifically for this machine learning application, you will need to install again in that virtual environment your packages. What are those packages? Again, pandas. We will be using here pandas, scikit-learn, for the different commands, machine learning commands, scikit-learn. You need scikit-learn for the different machine learning functions to streamline our, to make our machine learning activities here. And NumPy, SciPy, Matplotlib. So those are the packages that will be required here. So we have imported the data sets. We are now going to load that data set into our housing, or rather we will fetch the housing data. Actually, here we are just going to fetch it. So this one here is just going to create the function fetch housing data, and the load housing data is not included yet here. So this one is just going to fetch the data, and we once the data has been fetched, we now input the load housing data. We will load the data into our data frame housing. So this particular command will fetch the data, so it will activate this function fetch housing data. So this one here will just define a function, which is the fetch housing data function. This one is, this chunk here is defining another function, which is loading the data. Now this one is the command to fetch the data, and we are now loading that housing data into our data frame, which is housing. So I'm just going to run it. Okay, so as you can see here, you have the first 5 rows of your data. One good thing about Jupyter is that you can actually see all of the columns. Unlike in Spider, it's usually truncated. But anyway, so this the data, we have longitude versus latitude, the median age of the housing, total rooms, total bedrooms, population, the household's income, median house value, and ocean proximities. So we have, actually we still do not know yet the exact number of data that we have, or do we have a null data, because these are just the first 5 rows of the data that we have. So we want to know the extent of the data, so we get housing info. So this is to get the information of the data frame, the housing data that we have. So run this. So here you have 10 columns: longitude, latitude, housing median age, total bedrooms, population, households, median income, median house values, and ocean proximity. And then it will tell us how many do we have a null data, or the data that is not null, that is we do not have empty. So we have 2640, so that means around our data has 20,640 rows. And from here you can see total bedrooms, it's less than 20,640. That means in the total bedrooms column we have empty data. And then here we have, all of them are float, so numerical, but this one is object, so that is a categorical data. So we have around 20,600 data. We have some empty cells, and we have a categorical data. So that is our data that we have, so we will be working on. So for the categorical data, so you can see here, this is the categorical side, so you can see nearby. So we can actually it's consistent how many different categories do we have. So this is to inspect the categorical data. So since I'm lazy, I'm just going to copy paste it in our demo notebook. Okay, so we have inland, near ocean, near bay, island, and ocean. So proximity to the ocean. Also, some of them are directly in the ocean, probably. So these are the different categories in the ocean proximity column that we have. So next, we want to visualize the data. So here is the visualization, but let's try to run it in our demo anyway. So just copy paste. Okay, so still running. So since we are using Matplotlib here to view it as a to view this data as what to call that, histograms. So we just separate it with in 50 bars. So this is the histogram. So as you can see, the longitude and latitude really quite spread out. You have the median age, not normal distribution. We have total rooms, total bedrooms, again skewed on one side. We have the median income. At least it looks like a somewhat like a normal but a skewed distribution. Again, the median house value is also skewed, and we also have a ceiling amount at 500,000. Is it 500,000? So anyway, that is our video that we have. So as you can see, they are not normally distributed. So that's the fill of the data. So for the median income, so as you can see, we have, since a median income is a continuous numerical value, so for us to better know our data, or rather to better extract information, let's divide it into categories. Actually, we are also doing this because our sampling will be a stratified sampling. So why do we need stratified sampling? Because as you can see, these are not a normal distribution. So that means any sample that we will get here will it will be a challenge. We are not sure that if it will actually reflect our data population. So remember, in machine learning, we usually, the data that we have, the 20,000 data, we will divide it into two parts: the training set and the test set. So the training set will be used for training the machine learning model, whereas the test set will be used to evaluate whether the model is accurate. Now, this separation will be done randomly, and since our data is not normally distributed, we want to at least create a stratified random sampling, and we will do it using median income as an indicator, the median income of the client or the households. So that is why we are doing a category, or rather we are categorizing the median income. So the sampling here will be stratified according to the median income. So this is the median income. So this median income here, we had separated it into categories. So 5 categories, as you can see here. So again, as you can see, it's skewed to the left with a tail at the right, a longer tail at the right. So skewed to the left, longer tail at the right. So this is our categorized median income. So next, we will be doing the stratified sampling. So this is just the code, just copy paste the code. So here we are going to use this is from scikit-learn. The scikit-learn package, it gives us the function stratified shuffle split, which split our data into a test data and a training data. So just run this one. Okay, so this is stratified based on the income categories, these categories that we have. So this is basically the amount, the general amount of the data that we have from each category. And then we will also, the next one is we will drop the category, the income category. We only introduce the income categories because we want to stratify our sampling. Now that we have already done it, we will drop the classification because it might affect the actual data that we have, because we want our algorithm to learn based on the actual median value, not the bins or the categories that we arbitrarily introduced. Now we have we load our train copy, or rather we get a copy of the training data and load it into the housing. So if you remember, housing is the data frame that we defined for the original 20,000 data. Now we will be replacing that data set with our training set, and then let's plot our data based on its position, longitude versus latitude. And as you can see here, longitude versus latitude, basically this can be superimposed into the map of California. What does California look like? So this is from the state of California, USA. So here, as you can see, elongated, somewhat a diagonal-ish strip of land. So this is your California, the map of California, which is this one. So in the dense regions here, basically this is because we set the shading at point 1. So the more concentrated data that we have, that means the darker or the denser the blue color. So as you can see, these are the near the bay areas or near the shorelines. We have concentrated housing near the shorelines. This is for the initial view of our training data. So let's look at another view of the training data. So this time we will introduce another parameter, which is the median house value. So this is based on the color, and we will introduce a color map or a color bar for each housing value. So this is your map now with the introduced housing value. So this is the median score. So that means the red ones, expensive houses. Expensive houses tend to cluster around the shores, the bay and the shoreline areas. And then further inland, you have the lower values of the housing. Median house value is a lower median. Okay. So the next one, so we have now we will do a scatter matrix. So let's see if there are any correlations among the data that we have. Is the housing prices correlated with the other with say the income, the district, the longitude versus the longitude versus latitude, and so on. So how are the different data are related to one another? So here are the scatter plots of each data. So this is, for example, median house value versus the median income. So the Y is the house value, the X is the median income. So as you can see, there is actually a correlation here. So as your house value increases, your median, as your median income increase, you have increasing house value. So the reverse of that plot is this one. Then for the other parameters, this is the median income versus total number of rooms. Doesn't really have much of a pattern. They just tend to cluster around this middle part. The housing age is totally scattered around. So there's basically almost no data here. Median age, or basically as you can see, the median age doesn't really correlate with any of the parameters that you have. Total number of rooms might be correlated with the house value, of course, and the income. But as you can see here, the one of the more prominent correlations is on the income and the house value. But again, we cannot oversimplify it based on just simply the median income, because as you can see in our graph here, the housing prices is also affected by the location. It's tend to cluster around certain regions, or rather the more expensive houses tend to cluster around the shoreline region. So it might also have effect on declaring housing prices. Okay, now let's clean the data. So remember, we have non-null values in the total bedrooms. So in this case, we want to fill that values. We do not want zero values. It might affect greatly our the machine learning algorithm. So we will fill the empty values with the median. Unlike the previous, we just fill it with 0. We will fill it with the median because the column is labeled total bedrooms. Having a 0 total bedrooms doesn't really make any sense. So let's just go for the median, which is a safe choice. So here, you fill it with the median and then check if you have any more empty data. So as you can see, they have the same non-null values. So basically, you have no empty cells now. But again, we have this ocean proximity, which is a categorical data. Now, to deal with the categorical data, we need, again, so looking at our, let's inspect that categorical data. So as you can see from the previous original data that we have, so this is 20,064 and this is the amount of the categorical data. And then for the info now, we have a different values. So this is because the same this for this one. This is because we already divided the data into the training data and the test data, and we are just looking at the training data only. So it's less than what we have seen originally when we first inspected the data. Now, this is for the pre-processing. So, for the ordinal data, because this is a bit problematic, we can just order it, assign grades or numerical values to each category. But for our cases, this is not really recommended because this type of categorical data is not ordinal. This is just basically it just describes whether your the house is in the ocean or near the ocean, inland, near the bay, etc. So the one that is recommended here is to create a one-hot encoder. It basically separates the data into basically it creates an array where your data are where exactly for example we have 1 2 3 4 5 categories, so it gives us an in the array. So if it's in the ocean, it's the ocean, so 1 0 0 0, so that's the array of the first data. If it's near the ocean, you have a 1 for this category and 0 for the rest. So we the one-hot encoder is just going to transform the categorical data into an array. So okay, so that is your array, and then put it basically our array now, as you can see, 1 2 3 4 5, so that corresponds to each of the encoder categories. So this one is for ocean, this is in island, near bay, near ocean, ocean, inland, island, near bay, and near ocean. So for example, this cell here, that means 100, this the entry here is ocean. For this cell here, sorry, the cell here is inland, and then this one here is the fourth one, 1 2 3, the near bay, this near bay, and then this is near ocean. So anyway, that's how it transforms your categorical data. And then we will do custom transformers for the other numerical data. So we will be doing hyperparameters. So this is, we are just setting parameters for the machine learning that we have, and this is from the transformation pipeline. So we will do an imputer, attribute other, and standard scalar. So basically this is just a simple sample prep. So this is in preparation for the actual machine learning. Now, this categorical data that we had a while ago, we will encode it back to our housing, because this is just for the numerical. So the transformation that we did is for the numerical data. Now we will add the categorical data that we had prepared here a while ago back to the training data that we have. Okay, so now the training that we have is now in your data frame called housing prepared. So we will now train our model. So we have discussed 3 models here: the linear regression, the classification or decision tree, and the random forest. So let's try one in turn. So let's first have the linear regression model. So we will get the linear regression model from scikit-learn. Just run it. Okay, so this is how fast, quite fast. this is just a simple linear regression. We had trained an algorithm with predicting the housing prices using a linear regression model. So let's evaluate. So that means we already taught the machine, so that's quite fast because we have just a small amount of data. And then let's evaluate. So this is for evaluating the model. So in this evaluation, we got some data from the test data that you have, and we will use the linear regression to predict the data that we have. So now, and it will print the prediction. And to get the performance, we already discussed in the previous video, we will be using the root mean square error to calculate how far the prediction is, or rather how accurate our prediction would be. So the predicted values, this is for the each for the different values that we have. So the predictions, these are the prediction and this is the actual data. So it's quite near, but not that near enough, with an RMSE value of 68,000 for the median housing. Okay, so we did the linear regression. So let's try with a different one, which is the decision tree. So using the prepared training data, we will teach a different model. This one, start from 0, decision tree this time. So this is the decision tree regressor. Okay, so you now have a decision tree regressor model. So let's evaluate it using the same data that we have from the linear regression. So let's try whether will it be able to predict. So here, the predictions versus the actual data. So it is able to predict quite accurately because the RMS is 0. So decision tree for this test data, for a single test data, it was able to accurately predict the parameters. Now, but remember, the model must be consistent, so it must not be tested only a single instance. So you need to check it also with, or rather, we need to run other sample test data here. So we will do a cross validation. So we will, remember, we set aside some. That doesn't mean only one data for testing, but some. A significant portion, usually is 30% of the data for testing. So we will now be using all of them to validate our models. So this is for the let's do it for both decision tree and the linear regression models. Okay, so I'm just going to copy my code. Okay, so this is basically we will be displaying the scores for the tree and for the decision tree and for the linear. So this is for the cross validation. So we will check whether our models will be consistent. So because decision tree, from our initial evaluation, it is able to predict quite accurately, or rather very accurately, the parameters. So is this consistent with the rest of the test data that we have? So running, so we will run a cross validation here. Okay, so this is the result. So for the decision tree, we have, these are the different scores. The mean of the scores is 71,000. So it's not 0, it's 71,000. Mean error. This is the mean error RMSE score. So we want a low RMSE score for us to know whether it's accurate or not. For the linear regression is lower. So actually, that means your linear regression model is more consistent and more accurate than our decision tree. So let's try the third model that we discussed a while ago, which is the random forest. So let's teach the model using a random forest algorithm. Okay, so random forest, if you remember, this one is an improvement on decision trees, because remember, decision trees is vulnerable to outliers, unexpected data, as well as this becomes inflexible as new data comes in. Decision trees tend to overfit the sample or the data that you have. That is why for a random forest, it is more of an improvement, parang level up of the decision tree. So you have in a random forest, it's called random forest because it's made up of multiple regression trees, and for each tree, or rather, you run the data in all of the decision trees inside your random forest regressor, and the consensus result for each decision tree will be the result. Okay, so now we had taught the machine using the random forest. As you can see, since random forest is a set of decision trees, it takes a while. Actually, the evaluation of the random forest model is quite long. Let's hope that my system would be able to run the evaluation faster. But as I said, it takes a while for because it doesn't mean that it's really quite long, but rather I'm blaming more my system, my processor as a simple Celeron. So I'm just, yeah, it's that not that fast. So while we are waiting, so basically this is the cross validation score. So we can just actually, I just adapted it from here. So cross-validation scores of our RMSE. So, okay, so while we are waiting for the results of this demo, this is from the previous one that I did. So the cross-validation score that I got is 50,242, which is better if you compare it from our linear regression and our decision tree. So my decision tree is around 7,700, the linear regression at 69,000. So this is the mean score, so much lower. So let's see if it's done. Yeah, it's still running. Okay, so anyway, by the way, we are doing, this one was I did a while ago. This one is for the demo. As you can see, the values that we have is 71,313, 69,000 for the other one. And then comparing it, this is 70, this is also 69. So we have different score values, although I'm just copy pasting the exact same code. This is because the training set are randomly chosen. So that means the training set that I have used is different from the training set that was used a while ago, and the same goes for the training set, or rather the testing set that was used for evaluation in this previous instance and the one that we are doing. Okay, still running. So anyway, that's as you can see here, it's still quite high, lower than both the decision tree and the linear regression, but we still have quite a lot of errors. Now, what do we do with that? So the next, you can actually you can fine-tune your decision tree, or rather the random forest model, or you can choose a different regression model altogether that might give you a better score. So this is basically fine-tuning. So still running. So anyway, but for our lecture here, we will stop at we obtained the data, we visualize it, we cleaned and prepared the data for machine learning, we taught we trained 3 different machine learning algorithms for our data: the linear regression model, the decision trees, and the random forest regression, and we evaluated the performance of each training model. So that's it for this demonstration. Actually, this is just an introduction for machine learning, so we will not be discussing about the fine-tuning models and other things. So I guess it might continue on later, but as you can see from the previous run, this is the usual score. So it's around 50. So anyway, that's the evaluation of our random tree. So for your exercise, it's just a simple individual activity. So please read and answer the activity on Blackboard. So that's it for the module 3 in data science. I hope you learned a lot in this course. So thank you.